When a statement A varies directly as B, or A is directly proportional to B, then we say that A is equal to K times B. So the K in this example, in this equation, is called the constant of proportionality. It will be the same value for that entire problem. So what we have here is called direct variation. So when we're dealing with direct variation, we say that A varies directly as B. We also can say that A varies inversely as B, or that A is inversely proportional to B. And when we say that, then the equation A is equal to K divided by B is implied. So we call this inverse variation. So if we're dealing with A is directly proportional to B, or A varies directly as B, then we have direct variation. A is equal to K times B. And when we have inverse variation, we say that A varies inversely as B, or A is inversely proportional to B, and the equation is A equals K divided by B. And when we have a sort of double direct variation, we say we have what's called joint variation. So the words varies jointly implies a double direct variation. So if we say peaches vary jointly as apples and raisins, then the equation would be P is equal to K times A times R. And if the statement is P varies inversely as apples and raisins, then it would be K divided by A R. So in some relationships, we have both direct and inverse variation, and that's okay. So if we would see A, the statement would be girls vary inversely as boys and directly as teachers, then it would imply that G is equal to K times T and divided by B all at the same time. So inversely as boys would be K divided by B, directly as teachers would be K times B. Note that K is always in the numerator. K is always my constant of proportionality. So we're going to look at these sentences and see if we can write an equation for these variations. If we read the numbers of boys vary directly as the number of girls, then we say B is equal to K times G. If the price varied inversely as the number sold, then we would say P is equal to K divided by N for number sold. The strawberries varied jointly as plums and tomatoes. So we'd say S is equal to K times P times T. Notice K is always in the numerator. The resistance is directly proportional to the length. The resistance is directly proportional to the length, which means direct variation, varies directly as, and is directly proportional to means the same thing. RPM is inversely proportional to the number of teeth. So RPM is inversely proportional to the number of teeth. So inversely proportional means the same thing as varies inversely as. Blues varied directly as greens and inversely as whites. So blues varied directly as greens, so K times G, and inversely as whites, so K divided by W. The water produced varied directly as the number of hydrogen burned. So water varied directly as the amount of hydrogen burned, so K times H for hydrogen. So the problems, we're going to work in 4 steps. But first, you may be given data to do some arithmetic. Look for a constant ratio of output-input values, or look for a constant product. And the reason why is because if y is equal to K times X, that's our direct variation equation. If y is equal to K times X, then the constant is equal to y divided by X. So if the y divided by the X is the same for every single ordered pair, then we have what's called direct variation. So 25 divided by 0.2 would be 5. That would be No, sorry, not 5. It would be 25 times 5, so it would be 125. And 62.5 divided by 0.5 would also be 125. So notice that y divided by the x is the same. Therefore, we have what's called direct variation. And my constant of variation is what I get when I divide the y by the x. So in this example, y is equal to 125 times x. So to get when x is 7, I would multiply 125 times 7. And the same thing for inverse variation. If y is equal to k divided by x, that's my inverse variation equation, then the constant will be equal to the x times the y. So if I multiply the x times the y for every single ordered pair and I get the same number, if it's constant, then that tells me we have inverse variation. So 0.1 times 3 is 0.3. And 3 times 0.1 is also 0.3. So every time I multiply the x times the y, I get a constant. And my constant is what goes in my equation. Y equals 0.3 divided by x is my equation. So now we're going to look at some problems where we can do direct, inverse, and joint variation. We're just going to do a couple. The number of boys in every class of a school varies directly as the number of girls. So the number of boys varies directly as the number of girls. In one room, there are 8 boys and 2 girls. So notice they've given me an ordered pair. So what I'm going to do is I'm going to plug in the ordered pair, 8 boys and 2 girls. 8 boys, 8 boys and 2 girls, so I can solve for k. K is 4. So that tells me my equation is b is equal to 4 times the number of girls. So now I know if in another room there are 5 girls, then how many boys? There would be 4 times 5 girls, which is 20 boys. So 2 steps. First, plug in the ordered, determine what equation you need. Plug in the ordered pair you're given to solve for k. And when you plug k back into the equation, then you can solve for the one you're looking for. So revolutions per minute vary inversely as the number of teeth in the gear. So revolutions vary inversely as the number of teeth. If 40 teeth result in 100 RPM, so there's my ordered pair, 40 teeth result in 100 RPM. Then multiply both sides by 40, and I'll get that k is 4,000. So my equation is that the revolutions per minute is equal to 4,000 divided by the number of teeth. So if now I want to know what would be the RPM if there were 50 teeth in the gear, 4,000 divided by 50 is 80. Okay, we'll do one more. Excuse me. Let's go down to number 6. The number of potatoes vary jointly as the number of mules and the number of farmers squared. So the number of potatoes vary jointly as, and remember, joint variation is a double direct variation. So k times something else. So the number of potatoes vary jointly as the number of mules and the number of farmers squared. So I'll make sure I square the farmers. Then they give me 5 mules, 5 farmers with 750 potatoes. So I'm going to plug that in. So I'm going to say 750 is equal to k times 5 times 5 squared. Let me get out my calculator. And we're going to do 5 times 25, because 5 squared is 25. 5 times 25 is 125. So I'm going to divide 750 by 125. 750 divided by 125 is 6. So my constant of variation is 6. So I'm going to write my equation. P is equal to 6 times m times f squared.